Good everyone, welcome. It is Geo Tutors. Yeah, we're back to it again, and we're going to talk about the qualitative. Sorry, that's a qualitative, quantitative analysis or quantitative interpretation. Okay, so we're going to look at different questions that might be asked to find. Okay, one of the things I'm always mentioning the neutron distiller, measuring porosity. That's basic thing. Okay, I want to know, when porosity tells you, it tells you about what it has in store. Okay, so if you know the porosity, you know if it is a good reservoir, if it's a poor reservoir, if it's a very, very good reservoir, if it's an excellent reservoir. So all of this tells us a lot of information. That's why I want to know about the porosity. Okay, so let's look at porosity. Review. So how do we find porosity, solve for porosity? Good. So the first thing first is for your porosity value, your neutron porosity log, the first thing is to draw a reference line. So you're going to draw a reference line. So you can look at your neutron, okay? This is your density, Abby. This is your neutron. So at this point, you're going to just take the average. Take the average of it. This is length, Abby. So just half it. Just take the average of it. Average of that length. Okay, the average of the length should be found around there. Okay? Yeah, I think so. Yeah. So that's the average of it. Good. So that average is your reference line. So you've taken the average. Okay, this guy is coming from this other side. This one is coming from here. So not from it doesn't have to matter if it's on the middle. Okay, in this case, you can see that the crossover happened at this junction here. Okay, so in this place now, what will be the average? The average will be around here. Abi? Can you see? But if it's here like this now, the average will be what? Will be here. So just like halving, you are halving the distance between it. Okay, so that is what you're going to use to check for your neutron density log. Okay, you're going to use this to calculate for it. Now, before that, I've always talked about the scale, okay, and we need to be conscious of that. Now, let's start with density log, okay. So, starting with please calculation calculation porosity of porosity using density log. Using density log. Okay, how do we go about it? Good. The first thing you have to notice your scale. So what does each interval, what does your increment, what is the increment? Increment of the vertical lines. Increment of the vertical lines. What does it mean? So I want to get the increment of the vertical lines. I think I told you how to get the increment of the vertical lines. Okay? Is the what? The total over what? Number of what? Vertical lines. Total over number of vertical lines. I tell you that what? Total is what? Upper limit minus what? Upper limit minus what? Lower what? Limit. Okay, so if you look at density log, can you see a density log very well? So you saw that in this point here we have 1.65, right? And here you have what? 2.65. 1.65. It's not everything that have to start from zero, okay? 2.65. And you'll be like, oh, why is it like this? Don't worry. It's kind of easy. So your total here will be what? 2.65 minus what? Upper limit minus what? Upper limit is the high number on this scale. Okay. And lower limit. What is lower limit? 1. What? 65. And that will give us what? 1.00. Okay, good. Now how do I get my number of vertical lines? I told you that it's increment you are doing. So while ignoring the first line, just count the number of vertical lines you have. So 1, okay, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So number of vertical lines is what? vertical lines, number of vertical lines is what? 10. So what is my increment per lines? My increment per vertical lines per line will be what? So as I'm increasing, as I'm counting the lines, I'm increasing by something. So I want to know that units. That's what I did. I'm doing this calculation. 1 over 10 is what? 0 point what? 1. This is something that you can just do with your eye if you get used to like the analysis. But I'm just breaking it down for you so that you can just get used to it. So 0.1 increase. That means if I'm moving line, if I have 10 lines here now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Yeah, this is not the right scale. I'm using my hand. Okay. So each increment is what? By what? 0.1. I mean 1.65 plus 0.1. That's what? 1.75. Like that. As we adding 0.1 to it. Good. So how do I calculate? How do I know at what point a particular region is? Okay. So now let me give you the formula for porosity using density log. Now, looking for porosity using density log, how do you go about it? Now, recall. When do we recall? Okay, so this is density for matrix minus what? The bulk density minus density of over density of matrix minus what? Density of what? Fluid. Can you see that? So on our density log, you cannot get porosity direct. Okay, what you get is your what? Is your bulk density. Bulk density is gotten from the log. Is gotten from the log. Okay, density of matrix is based on the GR log correlation to the bulk density. To the bulk density. I'll explain all of this, okay? And density of fluid. Most time we use 1.0, okay, which is for water. So the kind of fluid that we have, although we have gas, we have some mud filtrate also as our fluid, but 1.0, just take it as a constant, okay? Predictional purpose. 1.0. There's not really complexity in this basic ball logging quantitative analysis. So you take 1.0 as your fluid, okay? Density of your fluid. Now, let's move on sharp and quick. Good. Now let's look at how to get our PV. So we need to get all of these guys, this guy and this guy. Okay. This guy is not actually add. So but let's do this guy first, then we'll come to this guy. Okay, the bulk density. Now, you have said earlier, you said that you do a reference line, like immediately you give it this, and you know the increment. Okay, so how do you do your quantitative analysis? Know how to count. Okay, know the increment and get this guy. Good. So how do I get my increments? How do I know what this thing means? This line means. Okay, can see my density login is moving from 1.65 to what? 2.65. So I want to know what this region means. What this region means. So what do I do? Very easy. So rather than me like adding, my increment per line is 0.1. Rather than me adding 0.1, 0.1, 0.1, 0.1, 0.1, 0.1 till this point, till this location, Abby, and getting my bulk density direct. Okay, so it might be stressful. Some people might not be able to like add it very, very fast. So what do I do? So what I do is this. I just count. So I want to get my region, Abby. So I just count. This is the starting point is what? Starting should be your lowest, Abby. So my bulk density will just be, this is my starting value on my scale. On scale is what? 1.65. So I remember I'm counting to what? to the reference line. I'm counting to the reference line. I'm counting to this line. Okay. So some people might just add 0.1, 0.1 like that. So what do? Rather than me wasting my time, I'll count the lines too, but I'll not be adding it immediately. So let me count my lines. So how many lines do I have till this place from the increment? I tell you, I'm counting. Don't count this first line, okay? Yeah, because it's increment you are doing. So this what? One, right? One, two. You are starting from the lowest. 1.65 is here. So now I'm starting here. One, two, three, four, five, six. Here is it's kind of more than half. This six, having this 67, like 6.6. Okay, like 6.6, 6.7, like more like 6.5. Sha. Okay, let's use 6.5. Let's say just at the middle. Okay, so we got 6.5. 6.5 vertical lines. Okay, so multiply this number of lines. Number of lines is what? 6.5. Have you? To the reference line. To the reference, you counted, let's do it again. 1, 2, 3, 4, 5, 6. 6.5, right? Because in the middle between 6 and 7, so 6.5. So if you can choose 6.6, you'll still be fine. So 6.5. Now multiply. So what is my increment? What did I say my increment is when we calculated? We said we got what? 0.1 increment, have you? 0.1 increment for my density log. So I'm going to multiply this number of lines. So multiply number of lines by, so 6.5 times what? 0.1. That's what? 0.65. Can you see that? So, but I want to know, because my stuff doesn't start from 0, I'm going to add it. So you know I counted 1, 2, 3, 4, 5, 6. Then this is my reference line, is Abi. This is my reference. This is my 1.65. So I counted 1, 2, 3, 4, 5, 6. This is my reference line. This is 7 here. This is 6.5. So, and I said that what? So I counted 6.5. And when I did my scale, I discovered that my increment should be what? 0.1 increase. I've done that in the beginning, okay? That doesn't iterate. So we got 0.65. So multiply that number of lines that you calculated. We got 6.5 here. This line represents 6.5. Multiply by the increment per line, which is what? 0.1. We'll get what? 0.65. Then add it. So 1.65 plus what? 0.65. That will give us what? So I carry my calculator, okay, 1.65 plus 0.65. That gives what? 2 point what? 3. Okay, so my bulk density is what? Is my bulk density, which is what? 2.30. I said earlier, it is gotten from what? It is gotten from your log. Okay, so we got this as what? 2.3. Good. Okay, so that's how we do it. Okay, so just write it in again. You count it to this point, then you count the number of lines, then multiply by the increment that we got when we started, because the increment. Okay, so we got that 0. Remember what we got now when we did 2.65 minus 1.65, we got 1 divided by 10, because 10 vertical lines, we got 0.1, which is 0.1 increase, okay, in density. So each line represents 0.1 increase. So instead of us doing plus 0.1, 2.65, 1.65 plus 0.1, that was, that's 1.75, 1.85, 1.95. That's like 2.05, 2.15, 2.25. Then like that, 2.3. You can see that it gave us something very close. Okay, so you can do like that if you are sure you're not be confused. So what I just do, I just count the lines, then multiply by that increment I got in the beginning, and add it to my lowest value, because I didn't start from. So just always add it to your lowest value in your scale. Good. So here is 1.65. So you have added that to it. Now the next thing you are going to do is okay, I've done neutron. So now your matrix. How do you get for density of matrix? Density of matrix is very, very kind of easy. So now if you look at your log, now where does this point is? This guy here is in your what? In your sandstone now. So because it's in sand, many a times it's always in the sand, sha. Because in your sand, okay, because in your sand region. So we use the matrix for sand. What's the matrix for sand? 2.65. So I don't stress you. So just 2.65 as your density of matrix. So the density of quartz, okay, the matrix for sandstone is quartz. Okay, that's a basic thing that's there that is not really with that. You see that sedimentology. So what just quartz for that. Okay. So there are times the time that you not use 2.65, you use 2.71. Mm, kind of blame now is when the lowest, when this region here, when this guy falls below, I think below 10. Yes. When this reading, okay, when this reading here falls below 10. So but you can see this region where you draw a reference line, if you correlate in this point, is the API here, is it 10? No, the API here is even 20. Here is 40. Okay, here at this point here, correlate with this guy. The API there, which means the what you are doing here is still sand. Even if it reach here, it's still sand. It has to be below half of here for you to know that they are doing with like limestone or carbonate or dolomite. But here's 2.65, okay? 0.65 for that. So now we know that here's one. So just do so our porosity, density porosity log is what? Um 2.65 minus 2.3 over 2.65 minus 1.00. So 2.65 minus 2.3, that's 0.35 divided by 1.7, 1.75. Okay, we have 0.2, 0.2. Okay, so our density porosity is 0.2. Okay, so let's mark it up for that. Now for our